Hey everyone, here's a quick video on multiplying radicals. So we've already dealt with simplifying radicals. Like when you have radical 48, I'll rewrite this stuff so that you can all see it at home a little bit bigger. Okay, so you have radical 48, you look for the biggest perfect square that goes into it, and that would be 16, and what's left over is 3. So we're used to that, right? Now we have to understand that this can simplify to 4 radical 3. But at the same time, we were able to simplify it by breaking this apart into something that's a factor of it, that's a perfect square, and whatever's left over. And if we were to multiply these two radicals, you'd think we'd end back up with 48. So you multiply what's basically under the radical. So you multiply the two radicands and get radical 48. So let's apply this to a couple other problems. What you want to do first on these problems is multiply and then simplify. So you have radical 15 times radical 6. 15 times 6 is 90, so we have the square root of 90. And now that we have the square root of 90, we can simplify that, right? Because we multiply the two radicands, got what's under our new radical. Biggest perfect square goes into 90 is 9. What's left over is 10, so we get 3 radical 10. It's a fairly basic concept. All you're doing is multiplying the radicands and then simplifying afterwards. So in this one, we throw a little wrench in. We have numbers out in front. Treat them just like numbers. Multiply them like they are numbers. 3 times 2 is 6. Radical 8 times radical 11 is radical 88. So we look for the biggest perfect square that goes into 88. And that happens to be 4. And we're left over with the radical 22. There are no other perfect squares that go into 22, so that's all we can do. Now we have 6 times the square root of 4 is 2. Radical 22. Combine your numbers and you get 12 radical 22. So treat the numbers like numbers, treat what's under the radicals like radicals. Combine them and then simplify. Alright, so let's look at a couple more examples. You're going to have a worksheet when you come into class where you're going to work with some partners. Just be ready to do these problems. This is sort of as far as it's going to go. So square root of 7x times the square root of 8x. Multiply the radicand so you get the square root of 56. X times x, remember we add the exponents, is x squared. So seeing that we have variables, we need to deal with perfect squares of variables and numbers. So we're going to do the perfect radical and the non-perfect radical. And the perfect radical, biggest perfect square that goes into 56. We have to figure that one out. That's 4. And we're left over with a 14. Now let's figure out the biggest perfect square that goes into x squared, which is x squared itself. Nothing's left over from that. So we can simplify that to be 2x. Simplify this whole thing. Radical 14. Next problem, we have cube roots. So leave the 4 on the outside for now. Multiply what's on the inside. 3 times 9 is 27. M times m to the 4th is m to the 5th. So we need to do the perfect, non-perfect. (27) is a perfect cube, so it's going to go in the perfect. We'll leave the 4 on the outside. M to the 5th. We need it to be divisible by 3. So the biggest number that goes into that is m to the 3rd. And an m squared is not perfect. So let's simplify that. You have 4 times square root, or cube root of 27 is 3. Cube root of m to the 3rd is just m. And then you're left with the cube root of m squared. 12 m cube root m squared. So it's pretty simple. Leave what's on the outside if there's nothing to multiply with. If there is, multiply it together. Like if we had a number out here, we'd multiply it by 4. Multiply the radicands underneath, and then simplify the radical in the end. So do one more example, or two more examples for you. 2 times the square root of 12x squared y times the cube root of 8xy cubed. Now, you're probably looking at this one and saying, well, this one's square root, that one's a cube root, what's he going to do? There's nothing I can do. This is the answer. You have to have the same index to combine them. So these different index cannot multiply, because they work by 2 different rules. This one's asking you to use the square root rules, this one's asking you to use the cube root rules. You have to leave them alone. So you'll see the index here, that's a cube root, nothing there implies a square root. If they're different, you can't multiply them. So let's try number 6. 3 times the cube root of 2x to the 4th times 4 times the cube root, or 4 times the cube root of 192xy squared. So multiply our numbers, 12. Multiply our radicands. So 2 times 192 is 84 x to the 5th y squared. So I need to find the biggest perfect cube that goes into 384. Let's see. So let's cut the number in half. We get 192. Let's look at our perfect cubes under 192. So we can try 125. That's not going to work. We can try 64. Oh, and there it is. It comes out as 6. So we have 12 cube root 64 in our perfect, and in our non-perfect we get 6. Remember, cut the number in half and test the perfect cubes or perfect squares below it, depending on the type of problem. Biggest perfect cube that goes into x to the 5th is x cubed, and you're left with an x squared. There's not enough y's to be a perfect cube, so we're going to leave the y squared in the non-perfect one. Simplify this out, you get 12 times 4x, right, by simplifying our perfect cubes, cube root 6x squared y squared. In the end, our answer becomes 48x cube root of 6x squared y squared. And that's about as difficult as it will get. You honestly just need to keep your rules in mind. Okay, remember when you're multiplying exponents, you add, or multiplying variables with the same base, you add the exponents. You can only multiply when you have the same index, multiply numbers like their numbers, multiply numbers like their numbers under the radical, and then simplify from there.